In case of emergency, the aircraft is equipped with firefighting, oxygen and first aid equipment strategically placed throughout the cockpit and the cabin. An emergency lighting system provides internal and external illumination when all other electrical power sources are no longer available. The oxygen equipment system is divided in two parts. A fixed system to supply cockpit crew members and passengers, and a portable oxygen system to supply cabin crew members. Other equipment is distributed strategically in the cabin and the cockpit. It consists of portable fire extinguishers, protective breathing equipment, smoke goggles, fire gloves, first aid kit, crash axe, megaphone, flashlights, and life vests. The regulation requirements for aircraft certified to fly at altitudes not exceeding 25,000 feet are to supply in oxygen the flight crew members the entire flight time when the cabin pressure altitude exceeds 10,000 feet, and to supply the entire flight time between 10,000 feet and 13,000 feet cabin pressure altitudes for all cabin crew members and for at least 10% of the passengers if the aircraft is able to descend safely within 4 minutes to a cabin pressure altitude of 13,000 feet within a minimum of 30 minutes. To comply with these requirements, the aircraft is equipped with a fixed oxygen system to supply the flight crew members and the passengers. Cabin crew members use portable oxygen bottles, which will be explained in the cabin emergency equipment module. Basically, the ATR has been designed to supply 25% of the passengers. The specific 30% or 100% of passengers' oxygen supply is subject to options. The fixed oxygen system is composed of 3 subsystems: the oxygen storage and supply, the flight crew oxygen distribution for pilots and observer, the passenger oxygen distribution. The oxygen is stored in a cylinder of 2,182 litres, 77.1 cubic feet, capacity, located in the flight deck behind the captain's seat. A pressure regulator reduces the oxygen pressure from the nominal 1,850 psi to 78 psi to be delivered in the distribution system. It is fitted with a transmitter to enable a monitoring of the oxygen pressure. In case of overpressure, the oxygen is discharged outside the aircraft by a safety circuit equipped with an overboard discharge indicator. It is possible to refill the oxygen bottle through a refilling port located in the cargo compartment at the bottom of the electronics rack. A crew feed stop valve enables the distribution system to be supplied or cut off. Then oxygen arrives in a distributor manifold, which is connected to the 3 flight crew quick donning oxygen masks, and the passenger distribution system. A pressure switch ensures the oxygen system pressure monitoring. A passenger feed stop valve enables the passenger distribution system to be supplied or cut off. Pressure is then released to the oxygen pressure regulator, which regulates the flow of oxygen in each passenger mask. The passenger oxygen masks are located in 17 modules above the cabin seats. Three quick donning oxygen masks are provided in the cockpit for both pilots and for the observer. They are stowed in a box for direct operation in case of emergency. It is an oral nasal mask comprising a plastic face piece with a comfortable silicone compound sealing pad covered with a high-quality elastomer. The mask is equipped with a ventilation system for utilization with smoke goggles. The harness inflation is carried out by action on the right clip. It is also equipped with an oxygen supply hose associated to a microphone connection. The microphone is attached on the oxygen regulator inside the mask. Oxygen system is controlled and monitored from the oxygen control panel located on the overhead panel, and also through the MFD system display cabin page. On this page, oxygen system is represented on the top left by a bottle with a vertical tube and two distribution pipes along it for the crew and passenger supply. A high pressure indicator is used to check oxygen bottle pressure. It is displayed in thousands of psi, and the scale is marked by two colored arcs. A red arc from 0 to 85 psi, and a green arc from 85 to 2025 psi. Nominal pressure is 1850 psi. If the pre-flight pressure is below 1400 psi, the quantity must be checked to be adequate for the intended flight with the help of the oxygen graph. The main supply push button controls the crew feed stop valve. When the push button is released, the valve is closed and off-white light illuminates. On the system display cabin page, the symbol for the oxygen system is white and pipes are shown empty. When the push button is switched depressed, the valve is open, the low-pressure oxygen supplies the cockpit crew oxygen masks. On the system display cabin, the bottle symbol becomes green and a green arrow appears to crew. The low-pressure amber light illuminates and flight warning system is activated when a pressure drop below 50 psi is detected in the low-pressure distribution circuit. On the system display cabin, the symbol becomes amber with an amber low-pressure flag. The passenger supply push button allows the control of the passenger supply valve. When the push button is released, the valve is closed, and it is represented by an empty pipe without arrow on the oxygen representation. When the push button is depressed, the passenger supply valve opens and an on blue light illuminates. A blue arrow appears to PAX on the system display cabin oxygen representation. In the event of a low pressure detected while the passengers are supplied, the passenger arrow becomes also amber. The cockpit crew oxygen masks are quick donning inflatable harness type. They are stowed in a container at each crew station. On the container, a blinker indicates by a yellow cross when there is oxygen flow and black when no flow. A test reset push button, when depressed, allows the oxygen flow test into the mask without removing it from its container. When the mask is deployed, It also allows the boom set microphone reactivation for communication. On the oxygen mask, an N100% rocker switch controls the type of oxygen flow delivered. N corresponds to an air-oxygen dilution, while 100% configuration enables to deliver pure oxygen without overpressure. 100% position is the normal required position. It could be locked by a rocker switch depending on the oxygen mask type. An emergency knob activates the pressurization of the oxygen mask delivery flow provided the N100% rocker switch is in the 100% position. The rotation of the selector in the direction of the arrow gradually increases the delivery pressure. When the knob is depressed, unstable position, a temporary overpressure is performed. Aircraft is on ground and oxygen system is off. You switch on the main supply push button in order to supply the cockpit oxygen masks. The oxygen flows through the crew feed stop valve, now opened, and through the distributor manifold to reach the masks. The oxygen mask test consists of depressing and holding the press to test and reset push button on the box. As oxygen flows, the blinker illuminates yellow for a short time, then turns back dark, and the oxygen flow can be heard throughout loudspeakers. Release the test push button. Depress and hold again the test push button and squeeze the red clips on each side of the hose at the same time. The harness must inflate inside the box. The last part of the check is to depress and hold again the test push button and depress the emergency knob in test position. You must hear the oxygen flow sound another time through the loudspeakers. Finally, the test is completed and the system is ready to operate. Now you are in flight. Let's consider a sudden depressurization of the aircraft. The cockpit oxygen masks are ready to be used. The flight crew members squeeze the red clips on the hose and bring the oxygen mask out. Apply the mask with its harness inflated on the face. Then release the red clips to deflate the harness to hold the mask in place. Adjust the mask if necessary with the straps located on the harness. Oxygen flow is automatically delivered and you can breathe normally. To enable the passenger oxygen module to be supplied, depress the passenger supply push button. Oxygen flows through the passenger feed stop valve and the oxygen pressure regulators before reaching the oxygen modules in the cabin. To release the oxygen masks in the cabin crew need to manually open the oxygen modules with a manual release tool, MRT. Once it is opened, the oxygen mask will fall down by gravity. The oxygen will be delivered into each individual mask only after the safety pin is removed. To stop the oxygen flow, you can either reinsert the safety pin or switch off the passenger supply push button on the control panel. To stop the cockpit oxygen mask flow, close the left flap of the oxygen mask box and depress the press to test and reset push button. According to the regulatory requirements, all cabin crew members must be supplied with oxygen for all flight time at cabin altitude comprised between 13,000 feet and 10,000 feet, providing the aircraft is able to descend from 25,000 feet to 13,000 feet within less than 4 minutes. To comply with the regulation, the ATR 72-600 is equipped with 2 portable oxygen bottles, located under each flight attendant seat. The oxygen bottle is a green cylinder containing 120 litres of oxygen and is composed of the following elements: a pressure gauge, an on-off tap valve, 2 fitting outlets. The high outlet provides 4 litres per minute for a maximum duration of 30 minutes. The low outlet provides 2 litres per minute for a maximum duration of 60 minutes. It is also composed of a carrying strap, a recharge valve, and 2 overpressure ports. The portable oxygen bottle is associated to an oxygen mask also located under each flight attendant's seat, which must be connected to the appropriate outlet on the bottle. To assess the passenger oxygen masks located in the cabin, a manual release tool (MRT) is necessary. This tool is available under each flight attendant seat. It is a flat metallic device equipped with 1 sharp end and 1 flat and curved one. The sharp end is used to open the oxygen modules. Note: the curved flat end is used to lock or unlock the lavatory from outside. In addition, for aircraft exceeding 5,700 kilograms or having a maximum approved seating configuration greater than 19 seats, protective breathing equipment (PBE) is required. It protects eyes, nose, mouth and provides a breathable chemical gas for a minimum of 15 minutes in case of fire, smoke or noxious gases. These PBE must be installed adjacent to each cabin crew member duty station and to the hand fire extinguishers. There are 4 PBE on board the ATR 72, 1 in the cockpit and 3 in the cabin. The PBE is a device that completely encloses the head of the wearer and seals around the neck with an elastic membrane. It is composed of a large clear visor, an oronasal mask, activation and adjustment straps, a neck seal, a chlorate candle, a Ka2 canister, potassium superoxide. The ATR aircraft is equipped with 5 emergency exits, 4 in the cabin and 1 in the cockpit for the flight crew members. The 2 front cabin emergency exits are Type 3. The passenger entrance door and the service door are considered as Type 1 emergency exits. According to regulations, an emergency exit sill height higher than 1.83 meters, 6 feet above the ground, when the landing gear extended, or after the collapse or the failure to extend of 1 or more legs, must be equipped with a device to enable passengers and crew to reach the ground safely. As ATR emergency exit sill height is lower than that minimum, there are no specific devices in the cabin except for the cockpit, which has an escape rope and integrated steps located on the electrical rack bulkhead. An emergency exit is considered as unusable when one of the following devices is inoperative: the external or internal exit opening device, the door open exit locking device to maintain the door in open position, the escape device, the associated exit emergency lights. The door open exit locking device is only fitted on the service door to maintain it in open position. It consists of a hook integrated in the skin of the fuselage, which deploys automatically when the door opens. According to the regulations, a commercial flight is prohibited when, on the same side of the cabin, more than half of the emergency exits are inoperative, or on the same side of the cabin, more than half of the floor-level emergency exits are inoperative, or one pair of emergency exits are inoperative. To sum up, on the ATR, a commercial flight is prohibited when either two front emergency exits are inoperative, or one of the rear doors is inoperative. And if one front emergency door is inoperative, the passenger capacity will be reduced to 59 in accordance with the minimum equipment list. Aircraft with a capacity of more than 9 passenger seats must be fitted with emergency lighting powered by an independent power supply to facilitate evacuation. For aircraft which have a maximum approved capacity of more than 19 passengers, it must include general illumination sources, a floor proximity emergency escape path marking system in the passenger compartments, an illuminated emergency exit marking and located signs, an internal lighting at floor-level emergency exit areas, an external emergency lighting at all passenger emergency exits. The emergency lighting power units must be capable to supply illumination for at least 10 minutes in the critical ambient conditions after an emergency landing. On ATR, the dedicated batteries are charged by the DC standby bus. The batteries are located in the cabin ceiling, and the floor path marking illumination is ensured by photoluminescent strips on the right and left aisle side. Regulations require that at least one hand fire extinguisher containing Halon 1211 or equivalent must be conveniently located on the flight deck for use by the flight crew. It is also required for aircraft with a maximum approved passenger seating configuration comprised between 61 and 200 to be equipped with 3 extinguishers easily accessible nearby the cargo compartment and galley. They must be suitable for the kinds of fires likely to occur in the compartment where the extinguisher is intended to be used. The ATR 72 is equipped with 3 halon extinguishers located in the cockpit, behind the first officer seat, and at the rear of the cabin, behind the right or left last seat row. A water extinguisher is also fitted and located in the first left overhead locker. The halon extinguisher is a red cylinder containing halon gas. It counts a pressure gauge, a carrying handle, a trigger, and 1 diffuser. It is efficient on all types of fire. The water extinguisher is a grey cylinder containing 2 litres of water mixed with an anti-icing additive. It counts a carrying handle with a CO2 cartridge, a trigger, and 1 diffuser. The regulation requests for aircraft with a maximum certificated takeoff mass exceeding 5,700 kilograms or having a maximum approved passenger seating configuration of more than 9 seats to be equipped with at least one crash axe or crowbar located on the flight deck. On the ATR, the crash axe is located behind the first officer's seat. It has an insulated handle up to 2000 volts, used to cut through light structure, panels and windows. In the cockpit also, protective gloves to grasp hot material or burning parts are located behind the captain's seat. Goggles are also provided in the cockpit to be used in case of smoke in the cockpit. The regulation requests to fit the aircraft with an electrical torch for each required crew member, easily accessible to crew members when seated at their designated station. 2 flashlights are located in the cockpit near each flight crew seat, and 2 are located under each flight attendant seat in the cabin. The flashlight counts a body with batteries, 1 lamp and 1 on-off switch. Aircraft with a maximum approved passenger seating configuration comprised between 61 and 74 must be equipped with 1 self-battery-powered portable megaphone. In the ATR 72, it is located in the overhead locker of the last right-hand row seat. The megaphone counts a mouthpiece, a push button, and a carrying strap. An operator shall operate a land aircraft with life jackets. When flying over water and at a distance greater than 50 nautical miles from the shore, or when takeoff or landing at an aerodrome where the path is so disposed over water that in the event of a mishap there would be a likelihood of a ditching. The life jackets are located below each crew member seat and passenger seat. 1 first aid kit must equip aircraft with passenger capacity below 99 passengers. On the ATR 72, the first aid kit is located in the overhead locker of the last left-hand row seat, and an additional one is located in the wall separation between the cabin and the forward cargo compartment. ATR offers the option to provide a standalone portable emergency locator transmitter which transmits distress signals on 121.5 MHz, 243 MHz and 406 MHz. It must be located in the cabin and it counts a transmitter, an antenna, a visual and aural indicator, an on-off armed switch, and a self-test push button. The emergency lighting system is controlled by the emergency exit light toggle switch located on the signs panel on the overhead panel. It has 3 positions. Disarm to deactivate the system. This is the normal position with engines stopped. Arm, which is the normal position in operation. The emergency lights will illuminate if the DC standby bus voltage is below 18 volts or if the 2 generators are lost. Extinguish if DC standby bus voltage is above 20 volts and at least 1 generator is running. On to illuminate the emergency lights. Next to the switch, a disarm light illuminates amber when the emergency light system is deactivated. The emergency lighting system can also be controlled on the flight attendant panel with the emergency light push button. When depressed, the push button illuminates red, and it forces the emergency lights to illuminate. This switch overrides the arm and disarm positions of the cockpit emergency exit light switch. To use the portable oxygen bottle, the following steps should be applied. Connect the sterile mask to the appropriate fitting if required. Fully turn on the on-off valve anti-clockwise to initiate the oxygen flow. Ensure the oxygen is flowing into the mask. A green indicator is present on certain mask types. To operate the protective breathing equipment, open the stowage box, remove the sealed bag containing the protective breathing equipment hood from the stowage box, remove the protective breathing equipment hood from the vacuum-sealed bag, don the protective breathing equipment hood, start the chlorate candle, place the oronasal mask against the face, adjust eyeglasses over the oronasal mask nose, adjust hood material below the neck seal. When the wearer begins to breathe through the oronasal mask, the exhaled breath is routed through the KO2 canister. The KO2 canister removes water vapor and CO2 and adds oxygen before the gas is returned to the interior of the hood for inhalation. If the chlorate cartridge fails to activate, the hood is still usable. The wearer will have to catch a deep, fresh breath and exhale strongly into the oronasal mask in order to activate the system. To use the halon extinguisher, follow the PASS steps. Pull the pin. Aim low at the base of the fire. Squeeze the trigger. Sweep from side to side. The extinguisher will last for about 7 seconds. The fire extinguisher should be held in an upright position. To use the water extinguisher, turn the handle clockwise until the CO2 cartridge is punctured. The safety seal will break automatically. Press the trigger and aim at the base of the fire. The extinguisher will last for about 30 to 40 seconds. For oxygen use, a specific graphic located in the Flight Crew Operating Manual at the Oxygen Limitation page allows the crew to easily compute the oxygen endurance. In case of emergency equipment failure, refer to the Master Minimum Equipment List MMEL of ATA 25.
Your answer is correct. 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 Your answer is correct.